So, today's notes are called Graphing Higher Degree Polynomials and in parentheses put sum and difference of cubes. All right, so this is the third lesson that I've taught you on graphing higher degree polynomials. So the first one, we had polynomials, they had either 3 or 4 degrees, and they all had 4 terms. And for those, I taught you how to factor by grouping. If you have 4 terms, if it's possible to do factor by grouping, that's one way you can solve for the x-intercepts, and then complete the rest of your graph from there. Last class, we graphed higher degree polynomials. On those, we used basic factoring for all of them. They all had a GCF, and once we took out the greatest common factor, what was left was a quadratic. And then that's how we just used basic P-chart divide and slide to factor those. That's what we did there. So another way I'm going to show you is if you have a sum of cubes or a difference of cubes, which y'all already know how to factor those, but if you have a sum of cubes or difference of cubes, how you would graph that, because you can't use factor by grouping. There's only 2 terms, not 4. You can't use basic factoring like we did last class because they're not quadratics, okay? And when you, if they had a GCF, when you factor it out, they're still not going to be a quadratic, so you can't use that method. So if you have a sum or difference of cubes, then you would do what we're going to do today. All right, you ready, Jared? So first example, let us graph x cubed plus 8. All right, let's talk about some things before we graph this. What is the y-intercept going to be? 8, very good. How did you know that? Any other reason? Okay. Whatever your constant is, everything that I've taught you how to graph, the constant is always your y-intercept. If there's no constant, your y-intercept 0. Remember, your constant is the term that does not have a variable, right? So in this case, your y-intercept is 8. How many degrees do we have? 3 degrees. So that tells us we're going to have how many zeros? 3 degrees is how many zeros? 3 zeros. Remember, zeros are the same thing as roots, solutions, where your graph crosses the x-axis. And let's look at end behavior. Is our polynomial in standard form, first of all? Yeah, it's 2 terms. Your highest degree is first, your least highest degree is last, right? There's only 2 terms, so highest to lowest. So when your problem's in standard form, look at the very first term to determine end behavior, which is x cubed. If you still don't know how to do end behavior, you got to go back and watch the videos that I posted for end behavior. So is your exponent an odd number or an even number? Odd. 3 is odd. Is your coefficient negative or positive? Positive. So we know odd, it's either going to be up, down, or down, up. If it's odd and positive, what's it going to be? It's going to end on a positive note. So it starts on a negative note. What is that? Down and up. Left side will point down, right side will point up. So we know all of those things without even doing any math, okay? The y-intercept, we can just look at the problem and tell. We can see how many degrees it has, so we know how many zeros it's going to have. End behavior, I can look at it and tell what it's going to be. But one very important part of your graph is the x-intercepts. And we can't just look at the problem and see what the x-intercepts are, okay? So that's why I've taught you different ways to do it. When we had 4 terms, we used factor by grouping. Last class, we had a GCF. When we took it out, what was left was a quadratic, P-chart, divide, and slide. There's not 4 terms, so we can't do factor by grouping. There's no greatest common factor. So if I can't factor anything out, I still have a cubic polynomial, okay? But is x cubed a perfect cube? Is 8 a perfect cube? And there's a plus sign, right? So what do we have when we have a perfect cube plus a perfect cube? What's it called? Look at the title of the notes. What is it? A sum of cubes. Thank you. A perfect cube plus a perfect cube is a sum of cubes. So we're going to factor that. We know how to do that. Remember, sum of cubes is a plus b times a squared minus ab plus b squared. I already taught y'all how to do that previously. When the sub was here, you had one assignment on factoring sum and difference of cubes. It was a review. We already know how to do this. But I'll go over it in detail. So to find a, you find the cubed root of the first term. So the cubed root of x cubed is what? What did I multiply by itself 3 times to get x cubed? X. So wherever I see an a, I'll plug in an x. B, to find b, you take the cubed root of the second term, and the sign doesn't matter because we're going to get the signs from the identity. So what's the cubed root of 8? 2. Because 2 times 2 times 2 is 8. If you're not sure, put it in your calculator. I taught you how to find cubed root of 8. So wherever you see a b, you're going to get a 2. So now I know my first parentheses is a plus b. What am I going to put in my first parentheses? X plus 2. If a is x and b is 2, then a plus b is going to be x plus 2. Now the second set of parentheses is the a squared minus ab plus b squared, right? Does anybody have a question so far? Michael, you have a question? So let's figure out what a squared is. Well, if a is x, what is x raised to the second power? X squared, right? Let's figure out what ab is. That means a times b. If a is x times b is 2, what's x times 2? 2x. So where I see an AB, we'll substitute 2x. And then we also need to find out what is b squared. So b is 2. What is 2 squared? 4. So now I'm going to use the identity a squared minus ab plus b squared. So a squared is x squared. The middle term I subtract according to the identity. I subtract ab, which we said ab was 2x. The identity says you add the last term, add b squared, which in our case b squared is 4. The 2x or the negative part? Okay, so the identity says whenever you have a sum of cubes, the middle term, the AB, you're going to subtract it. When you have difference of cubes, the middle term, you add it. Okay? All right, so how many solutions am I supposed to find? 3. Well, I've got 2 factors, right? One of my factors is x plus 2. Can I solve for x? Right, so I set it equal to 0. Subtract 2, x equals -2. So there's one of my solutions. My other factor was x squared minus 2x plus 4. If I set that equal to 0, I've got a quadratic term and a linear term. I just can't solve it like I did previously. It's the quadratic. I either have to solve by factoring, solve using the quadratic formula, or solve using the completing the square, because it is a quadratic. The highest degree is 2. So let's in our head real quick. If we were going to factor it, we would need two numbers that multiply to get 4, positive 4, add to get -2. So 2 times 2 is 4. What's 2 plus 2? That won't work, right? 4 times 1 is 4. What's 4 plus 1? 5. Even if we did -2 times -2 or -4 and -1, are we going to be able to add to get -2? No. So we can't solve by factoring, sadly. This is not factorable. So to solve, either we have to do quadratic formula, or completing the square. Since it's not factorable, to solve a quadratic, either the quadratic formula or completing the square. Give you a hint, whenever you have sum of cubes or difference of cubes, I've never seen the quadratic part be factorable. Not saying that it never is, but I really don't think it's ever factorable. I've never come across one that was factorable. So would y'all rather do the quadratic formula or completing the square? Yep. Guess what? I'm still going to do the quadratic formula. Because less mistakes are made when kids do the quadratic formula. All right, don't forget we already know one solution, but we get 2 solutions from the other factor because it had 2 degrees, right? Emily, bring that phone up here and put it on my desk, please. So let's bring down x squared minus 2x plus 4 and set it equal to 0. Thank you. Have it in a class. What is A equal to? What is B equal to? And what is C equal to? So quadratic formula, nothing new. We know how to do it. X equals -b plus or minus square root b squared minus 4ac all over 2a. Yeah. Jared, head up, please. You have to stand up, can't keep your head up. All right, y'all also had to do the quadratic formula when the sub was here, right? So you're reviewing quadratic formula. X equals, the formula says to substitute in -b. That's the opposite of b. So if b is -2, what are we plugging in? If I subtract a negative, what happens? Anyone? Double negative gives you a positive. So I'm not going to be putting in -2. I'm going to be putting in +2. This is the opposite of b. So if b is -2, we plug in a +2. Plus or minus the square root of b squared. So b is -2, quantity squared, minus 4 times a is 1 times c is 4. All over 2 times 1. You may have a question so far. This is all review. So x equals 2 plus or minus the square root of. What is -2 quantity squared? That means -2 times -2. +4. Then remember, do the minus 4ac all together. So -4 times 1 is -4, and -4 times +4 is -16. all over 2. So that gives us x equals 2 plus or minus the square root of negative 12 quantity divided by 2. What happens when you have a negative number under the radical sign? It's imaginary, right? And we learned a couple classes ago that if you have an imaginary solution, while it's a solution, it will not be a point on your graph, okay? So when I taught you how to do the quadratic formula and we had the test over it, you had to continue simplifying from here, okay? However, when we're just graphing, once I know that it's going to be imaginary, then there's no point in continuing to simplify, okay? So, and this is going to be 2 solutions. It's going to be 2 imaginary solutions. EJ, can you get that? So, because there is a negative under the radical, we will get 2 negative solutions. Asia, I know you weren't here, but I told them if I see a phone, it's mine till the end of class. So I need you to put that up, put your backpack up, and get your notes out. I said 2 negative solutions. I meant 2 imaginary solutions. Imaginary solutions are not x-intercepts. So we knew we were supposed to get 3 solutions, right? We knew that because we had 3 degrees. We got 1 real solution of negative 2. We have 2 imaginary solutions. And I would have to continue simplifying to tell you exactly what they are. But once we know they're going to be imaginary, you don't need to keep doing the work if graphing is the end goal. Do you want me to show you? I mean, you took a test over it already. Right. But I can tell you what the imaginary solution is. I'm not. Can you please keep your nose and mouth covered? All right, so when we draw our graph, our graph is only going to cross the x-axis at negative 2. That was the solution we found earlier when we set the factor of x plus 2 equal to 0. So we have 3 solutions, but 2 of them are imaginary. Your graph only intersects the x-axis at positive solutions. So only when x is negative 2. What was the y-intercept? 8. So we know that point. We know the y-intercept's 8. The x-intercept's negative 2. We also know the end behavior, right? Well, we only have 1 x-intercept. So the left side of that graph's going to point down. The right side's going to point up, and it's going to pick up that x-intercept. That looks kind of terrible. It should really look more like this when you graph it. More like this. Mine did not. It's not a straight line. I should have put a line like that. See if I can do a little magic erase in there. And there you go. Anybody have a question about that? So the hardest part of this is remembering how to factor sum of cubes and difference of cubes. But again, this is a review, the factoring part. All of it's a review, really, except for just the graphing. All right, no questions on that one? All right, let's look at example 2. We're going to graph x cubed plus 64. Can we do factor by grouping? That I taught you a couple lessons ago. Can we do factor by grouping? You gotta have 4 terms to do factor by grouping. Do I have 4 terms? No. So can I do factor by grouping? No. Do I have a GCF? No. So we can't do it the way we did last class. Okay. Well, x cubed is a perfect cube. So maybe this is a sum of cubes or difference of cubes. Is 64 a perfect cube? Yeah. And remember, if you don't know, in your calculator, you do cube root, you do 64, and then second the button right below off, and hit 3 for cubed root, and as long as you don't get a decimal, it's a perfect cube. So what's the cubed root of 64? 4. So is this a sum of cubes or difference of cubes? Sum of cubes. If there's a plus sign, plus means sum, right? Sum of cubes. So first of all, before I start factoring it, what is my y-intercept going to be? 64. We're probably not going to graph that because that's going to be way on up there. Okay. How many degrees do I have? 3 degrees. So how many roots or solutions or zeros am I going to have? 3. Now we just learned, does that necessarily mean they're all 3 going to be on the x-axis? No. If I have 3 real solutions, they will all be on the x-axis. But if any of them are imaginary, you won't see them on the x-axis. Okay. And what is my end behavior going to be? Down and up. I have an odd positive. So that's down and up. All right, so we know all of those things, but the reason we have to do the whole math part is for the x-intercepts. Okay, so how we're going to find them is we're going to solve x cubed plus 64. So we could set it equal to 0. To solve it, it's a sum of cubes. So we're going to solve by factoring. We know to factor a sum of cubes, first set of parentheses is a plus b. Second set is a squared minus ab plus b squared. Difference of cubes, 2 of the signs are different, right? So we need to figure out what is a and b. Well, a is talking about the cubed root of the first term. So to find a, find the cubed root of the first term. So what is the cubed root of x cubed? X. So wherever I see a plain old a, I'll substitute in an x. B is the cubed root of the second term. Don't worry about the sign. Just take the positive absolute value. The signs will come from my identity. What's the cubed root of 64? 4. We just found that on the calculator, right? 4 times 4 times 4 is 64. So the cubed root of 64 is 4. So do I know what's going to go in my first set of parentheses? Do I know a and b? X plus 4. And then to see what goes in the second set, I got to find a squared, ab, and b squared. So a squared, take whatever x is and square it. So what am I going to substitute in for a squared? X squared. Then I'm going to subtract a times b. Well, what's a? Times what's b? What's x times 4? 4x. So wherever I see an AB, I'll substitute in 4x. And then I'm going to need a b squared. So b is 4. What's 4 squared? 16. Again, that's review, so I'm going kind of fast. So the second set of parentheses, my first term's a squared. What do I write? X squared. What's the sign of the middle term? Minus. What is the middle term? What's the sign of the last term? And what is the last term? 16. I know I'm supposed to have 3 solutions. Right now, one of my factors, x plus 4, I can set that equal to 0 and solve for x, right? What am I going to get? -4. So I know one of my solutions. My other factor is a quadratic. I can't just solve for x like I could for x plus 4. So if I subtract 16, I still have x squared and -4x. I can't just solve for it. You have a quadratic to solve. You either have to do factoring, quadratic formula, or completing the square. Jared, go ahead and stand up, please. Stand up. Are you refusing? Your eyes are closed and your pencil's down. So either stand up or I'll need to call somebody and let them know you're refusing. Okay, got it. All right, so let's think about it. Will 2 numbers multiply to get positive 16 and add to get -4? We got 8 and 2, 4 and 4, 16 and 1. If I change the signs on any of those, will they add to get -4? No. And remember, I just told you on the last one, whenever you have sum of cubes or difference of cubes, the quadratic, I've never seen one be factorable, okay? So go ahead and move right on to quadratic formula or completing the square. So if I'm doing quadratic formula, what is A equal to? 1, it's coefficient, right? What is B equal to? -4. What's C equal to? 16. So quadratic formula, x equals -b plus or minus square root b squared minus 4ac all over 2a. All right, x equals. What is the opposite of b? If b is -4, what am I going to substitute in? +4. Plus or minus the square root of b squared. So that's -4 quantity squared minus 4 times a is 1 times c is 16 all over 2a. So in this case, that's 2 times 1. Anybody confused? All right. So we have x equals 4 plus or minus the square root of, what's -4 quantity squared? +16. Let's do the minus 4ac all together. So -4 times 1 is, and -4 times +16, -64. Am I going to get 2 real solutions or 2 imaginary solutions here? Imaginary. Because, right, I'm going to have a negative under the radical sign. So that means I'm going to get 2 imaginary solutions here. If I was taking a test and the test was over solving quadratic formula and you wanted to get it correct, you would have to continue simplifying. But I'm solving this so that I can graph it. Graphically, once I know that it's imaginary, I don't need to continue solving it, okay? When you're doing your homework, I want to see that you get to this point before you stop before you stop doing the quadratic formula. Okay, once I see that you have that negative number, you don't need to do it any further. But if you don't do this part and you're like, oh, it's probably imaginary, then you're going to lose points on that. Okay, so I do have 3 solutions. One real solution of x equals -4, and then 2 imaginary solutions. So how many times, Brian Franco, can you keep your head up, please? Is my graph going to cross the x-axis? Only once, right? So we have what we need. It's going to cross the x-axis at -4. And my y-intercept was 64. We don't need to draw all the way up to 64, okay? My end behavior, the left side was down, the right side was up. When you have a quadratic, or I'm sorry, a cubic polynomial, it's not a straight line. So you're going to see like a bend in there at some point. We're just sketching. So I would be happy with your graph looking like this. Don't do a straight line. You don't need to go all the way up to 64 on the x-axis, or I'm sorry, on the y-axis, not necessary. And there you go. Easy peasy, right? Let's do one more. I mean, sometimes you just do. Usually on sum of cubes and difference of cubes, usually imaginary, that second step. But I still want to see your work to. I've never seen it not be Lakin. I've never seen it not be imaginary, but I still want to see your math because we need practice on quadratic formula. All right, example 3. So this is going to be my last example. If y'all need more, I can do more. And then I'm going to give you an assignment. And then once you finish that assignment, the majority of you owe me sub work. And if it's not turned in today, 60% is the maximum you can get. So that's what we're going to do after you finish today's assignment. And remember, y'all had over 7 hours of class time to work on sub work, and a lot of you did not turn in anything. So I'm being more than fair. Okay, first of all, what's my y-intercept here? -1. We can put that on a graph. That's pretty easy, right? How many degrees do we have? 3 degrees means we're going to have how many solutions or roots or zeros or x-intercepts? 3. What is my end behavior? Down and up. It's odd and positive, right? Down and up. Is there anything else I can tell about the graph just by looking at the problem? Odd because you always look at your first term when in standard form, right? Odd or even comes from the exponent. Your exponent's the odd number. The positive comes from the coefficient. Your coefficient's a +1. I don't care if your coefficient's odd or even. I care if it's positive or negative. So your coefficient's positive. That's where you got the positive from. Okay. All right. Is there anything else that I know about the graph just by looking at the problem? No. So we have to figure out, okay, we know what the y-intercept is. We can tell just by looking at whatever the constant is. But your x-intercepts is where the problem comes in, why we have to do the math. So this is a cubic problem. There's only 2 terms, so we can't do factor by grouping. There's no GCF, so there's no chance we could solve it like we did last class. X cubed is a perfect cube, is it not? Is 1 a perfect cube? And there's a minus sign. So what kind of problem is this? Difference of cubes. A difference of cubes has a different identity than sum of cubes. It's very similar. The only thing difference is 2 signs are different, right? So what would I put in the first set of parentheses? Y'all remember? Instead of a plus b, what do we put? A minus b. What's the first term in the second set? But what's the first term in the second set? A a squared, and then yes, plus ab. Nope. The last term, the b squared is plus on sum of cubes and difference of cubes. The only two signs are different is the sign between the first two terms in the first set and the middle term. The last term is positive for both of them. Coolio? So now let's figure out what a and b are, and then we can factor it. So to find a, you take the cube root of the first term. So what is the cube root of x cubed? X. B is the cube root of the second term, the absolute value of the second term, 1, because 1 times 1 times 1 is 1, right? So what are we going to write in our first set of parentheses? X minus 1, very good. The sign comes from the identity. Whatever the sign in the identity says, that's what we use. Now we need to find a squared. So a of x, what happens when we square x? What do we get? X squared. Easy enough. Then we have to find a times b. So a is x times b is 1. What is x times 1? Just 1x, which we call x, correct? Then we have to do b squared. So b is 1. What is 1 squared? 1. We have everything that we need to figure out what the second factor is. Yes. What will we substitute in for a squared? X squared. What's the sign of the middle term? Plus. What's a times b? X. What's the sign of the last term? Plus. What is the last term? 1. So we have factored. My first factor is x minus 1. If I set it equal to 0, can I find the solution? What is it? 1. So one of my solutions is positive 1. How many solutions am I supposed to have total? 3. Only real or imaginary solutions are the x-intercepts. Which one? So your imaginary solutions are the x-intercepts? No. Only the real solutions are the x-intercepts. So we have one real solution currently, but we still have that other factor, x squared plus x plus 1. This is a quadratic. Quadratic because your highest degree is 2. The only way to solve a quadratic is either factoring, quadratic formula, or completing the square. Is this going to be factorable? Two numbers that multiply together to get 1 and add to get 1. No, and I already told y'all, whenever you have sum or difference of cubes, that quadratic's never going to be factorable. As far as I have ever seen, it's never been factorable. So we can either do quadratic formula or completing the square. So let's do quadratic formula. What is a equal to? What is b equal to? And what is c equal to? All right, easy enough. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Yeah. All right, x equals, what are we going to put in for negative b? B's positive 1. Negative 1. Got to change the sign, right? Plus or minus the square root of 1 squared minus 4 times a is 1 times c is 1 all over 2 times 1. So let's simplify. X equals negative 1 plus or minus the square root of, what's 1 squared? 1. And then do minus 4ac all together. So negative 4 times 1 is, and negative 4 times 1 is negative 4. Am I going to get real or imaginary solutions? Imaginary, because 1 minus 4 is negative 3. So these are two imaginary solutions. since my goal is not just solving the quadratic formula, but it's graphing, is it necessary for me to simplify that all the way? No, once I see that it's negative, it's not going to be useful to my graph. Again, if you don't do that part on your assignment, you're going to lose points, okay? I need to see that you proved that it was imaginary before you just assumed that it was imaginary. Yes, Ezekiel. What are they? Well, one of them would be -1 plus I square root 3 quantity divided by 2. And the other one would be -1 minus I square root 3 quantity divided by 2. But once I know they're imaginary, I don't really need to find them, okay? When I'm graphing. If I just said, hey, here's a problem, I want you to solve it with the quadratic formula, you would need to continue. But when I'm graphing, your imaginary solutions don't do me any good for the graph. So I don't really care what they are. Once I know they're imaginary, okay, that's not gonna help me with my graph. You know what I mean? Okay, so how many times is this graph gonna cross the x-axis? Once. At 1, correct. At 1. And what was my y-intercept? No. It was what? -1. And what's my end behavior? So that gives me what? Down and up? So my graph's going to look something like this. Just because you have 2 points, it's not a straight line. A straight line is what happens when you have a linear function. Cubic functions, sum of cubes, difference of cubes are just going to be like that S-curve, okay? Do we need more examples? Okay. So your assignment is only 3 problems. It is only 9:39. Probably a lot of you will finish this assignment during class. And then I believe I have all of your grades updated. If not, that's what I'll do right now while y'all do this. Once you finish this assignment, go see what did I miss from when the sub was here that I did not turn in, because if I don't turn it in by the end of the day today, the maximum credit Miss Rayleigh is going to allow is 60%, and she already extended the deadline, right? And we're not waiting till the end of the quarter to decide what can I do to get my grade up when you have all these opportunities along the way, correct? Okay, sleeping, chilling on your phones, not what we're doing. Yes, Ezekiel. You can turn on Schoology, but this afternoon, okay? Like after school is fine. You can turn it on Schoology, not tomorrow, today. Yeah. Yes. So it's sum of cubes if you have a perfect cube plus a perfect cube. It's difference of cubes if you have a perfect cube minus a perfect cube. Difference means minus, sum means plus, right? Okay. All right, so I'll end my video and then I will post the assignment on Schoology. Anybody watching this from home? Hold on, Tylen.